This is Chapter 14, Periodic Trend Notes, and the first thing that we're going to talk about is the periodic law. Periodic law says that when elements are arranged in increasing order of atomic numbers, that would be the number of protons in a nucleus, there are trends or patterns in their chemical and physical properties. So the first thing we're going to do is we're going to talk about shielding electrons. So let's go ahead and write a definition down for that. Shielding electrons are the inner shell electrons that shield valence electrons from the nucleus's positive attraction. So negative electrons are going to be attracted towards the nucleus, which is positive. The first thing we're going to look at is what happens as you move down a family. And what happens here is the number of shielding electrons increases. So we're going to take a look at two different elements. We're going to look first at lithium, and then down below it we are going to look at sodium. So let's first look at your periodic table. And if you look at your SOL chemistry periodic table, you'll see that the electron configuration for lithium is 1s2, 2s1. Let's go ahead and draw a Bohr model of what that would look like. We would have 3 protons in our nucleus, and then we would have 2 principal energy levels. 1, 2. In the first principal energy level, we have 2 electrons, and in the second principal energy level, we have 1. This is our valence electron. These, right here, are the shielding electrons. So we have 2 shielding electrons. Now let's take a look at the next member of the alkali metals, and that is sodium. Sodium has the electron configuration of 1s2, 2s2, 2p6, 3s1. If we draw the Bohr model for sodium, we have 11 protons in the nucleus, and then we have 3 principal energy levels. And let's populate the principal energy levels. We have 2 electrons in the innermost shell. We have 8 electrons in the second principal energy level. And then we will have 1 valence electron, just as lithium has 1 valence electron. Now in this case, our shielding electrons are all the electrons that are inside the valence shell. So I'm circling all of our shielding electrons. So we have a total of 10 shielding electrons. And these shielding electrons are protecting this valence electron from feeling the full positive charge of the nucleus. So this is what happens as you move down a group. The number of shielding electrons increases. We went from 2 shielding electrons to 10 shielding electrons. Now let's see what happens as you move across a row. In this case, the number of shielding electrons stays the same. So what we're going to do in this case is we're going to move across the row from lithium. We're going to go all the way to the noble gas neon. And the electron configuration of neon is 1s2, 2s2, 2p6. It has a full valence shell. We're going to put 10 protons in the nucleus for a charge of 10 plus, and then we're going to put the 2 principal energy levels on. We're just looking at shielding electrons at this point. So we have 2 electrons in the first principal energy level, and we have 8 electrons in our valence shell. Now let's put a little oval around our shielding electrons. And you can see as that we go across the row, we still have just 2 shielding electrons for this entire period. So the number of shielding electrons stays the same as we move across a row. It increases as we go down a column.